Welcome to solverfy.
Okay, we have 3.96 times 10 to the 22nd molecules of dioxygen difluoride. And the question is, how many grams of dioxygen difluoride do we have? Well, how do we usually assess the number of grams of something when we're talking about chemistry and we're talking about large numbers of those molecules? We look towards the molecular weight, right? Because we know molecular weights relate grams to moles. Now, we don't have moles, we have molecules, but I think this information will still help us. So the molecular weight of dioxygen difluoride is 69.996 grams per mole. Now, if we knew how many moles of dioxygen difluoride we had, we could ascertain how many grams of dioxygen difluoride we have, right? There's one other caveat here. We want to know how many grams of fluorine are present in particular, right? And this would tell us how many grams of oxygen and fluorine are, the sum total of oxygen and fluorine. So while it seems like this would be exactly where to go, what we actually want is the molecular weight of F2. Because if we take the number of moles of dioxygen difluoride we have and multiply it by the molecular weight of F2, that will give us the weight in grams of just the fluorine that is present in our sample. So really, if we look up F2 molecular weight or calculate it from the periodic table, we will get 37.99681 grams per mole, right? Perfect. Now, let's take a look at how many moles we have, given that we have 3.96 times 10 to the 22nd molecules. How do we convert molecules to moles? Well, that's exactly what Avogadro's number tells us. Avogadro's number tells us the number of molecules in a mole. In particular, we know that there are 6.022 times 10 to the 23 molecules in 1 mole, right? So now, with this factor, we can convert molecules to moles, and once we have moles, we can convert moles to grams. We just need to set this up properly. So let's say 3.96 times 10 to the 22nd molecules. And if we multiply by the inverse of this conversion factor, we'll put molecules in the denominator and moles in the numerator, which is what we want, times 1 mole over 6.022 times 10 to the 23rd molecules. Right? And then that would give us, after we cancel the unit of molecules, moles. So we still got some work to do. We need to convert moles to grams. So we'll use the molecular weight of F2, 37.99681 grams in every 1 mole. Moles will cancel, leaving us with an answer purely in grams. So now let's put this into our calculator, 3.96. And then I use the EE button to do 10 to the 22nd. I say EE22. Then I'm going to divide by 6.022 and do EE23. And then I'm going to multiply by 37.99681. And all told, I get the answer of 2.4986 grams. And if I want to round this to the correct number of sig figs, which in this case would be 3, I get 2.50 grams.